The nodes domain layer is almost finished. We have all of the value objects and entities we need, and in this part we are going to create the repository interface and also prepare the data transfer objects of the infrastructure layer. Hello, welcome to ResoCode, where we are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. Let's start off by finishing up the domain layer. So we already have the node entity, the ToDoItem entity, and value objects, which we have created in the last two parts. Now comes the time to create the interface of the inode repository or of the node repository, which will live in the domain layer. It's going to be completely independent of Firebase or whatever else you are using to store data and to push data around the network, so to say. And then the implementation of the repository, which we are about to define an interface of, is going to be in the infrastructure layer. So let's start off. We're going to right click on the nodes folder, create a new file. It's going to be called inode repository.dart, and this will be just an interface, which unfortunately in the case of Dart programming language means an abstract class. So inode repository. And this will hold only method definitions. It's not going to hold an implementation. That's why we call it an interface, because interfaces in other languages hold just the definitions. So what should we be able to do from our app on the nodes? Well, we can observe all of them. So we can, in other words, watch them all, watch nodes. This will use behind the scenes the real-time aspect of Firestore, that we can watch a collection of nodes. So then we can also watch only the uncompleted nodes. We're going to have a little switch in the user interface, which will tell the app whether to show all of the nodes or only the ones which are uncompleted. So watch uncompleted nodes. Then we want to do the basic create, update, and delete. So CUD. So basically we have the full CRUD functionality, CRUD, CRUD, but the read part, the R, read, is separated into two methods, watch nodes and watch uncompleted nodes. So now let's go ahead and implement what I've just written in the comments, right? Or not implement, just define in real code. So watching all of the nodes over a period of time is not a one-off operation. So this tells us that we are not going to use a future to watch nodes, but instead we are going to use a stream. Streams are asynchronous beings which operate over time. We can listen to streams and they are going to deliver us new results over time. In this case, whenever the nodes are updated on Firestore, we're going to get new results from this watch nodes method. So it's going to return a stream. And now comes the question, what is going to be the type which the stream holds? It's going to be called watch all. And the type which is going to be held inside the stream could technically be only the list of all of the nodes which are present on the backend. So we would do something like kt list to make it immutable, and the list will hold entities of type node. So far so good, right? We want to hold nodes, so this makes sense. And it would be a viable thing to do it like this, holding just a kt list of nodes. But we do not want to handle the errors of a stream in the regular way, where we have a bunch of hassle with the stream. We have to observe the errors separately, and it's just a huge mess, in my opinion. So again, just like with futures, we can put an either even into a stream. It's perfectly doable. So either, and this way we can group together the correct data with the possible failures. But now comes the question, which kind of a failure are we going to output from our node repository? Because currently we basically have only the value failures. They are specific to value objects. So whenever a value object is invalid, it is a value failure instead of the regular correct value. But here we need to operate with a different kind of value, which is going to tell us what went wrong on the backend. For that, we're going to create a brand new freeze union for the failures, of course, and it's going to be called node failure. So let's right click, new file, node failure.dart. It's going to live in the domain layer still. And it's going to be fairly simple, at least for now. It's going to be a F union. You can always get the code from the link in the video description, by the way. So it's going to be called node failure. Import freezed. Let's put here the PTF statement for freezed. Let's commence the beloved build command. So flutter pub run build run watch delete conflicting outputs. And while this is starting up, we can specify the first failure which is going to be present. And for now, this is going to be the only failure present here, at least for this part, and that's unexpected. So unexpected is also the class name. We can make it public, I guess. Unexpected, or maybe let's make it private actually, package private. So unexpected failure is going to be emitted from the stream whenever something unexpected happens, of course. And then we are also going to, in the future parts, add more specific failures, which are actually going to tell us something about what actually went wrong. For now, we are just going to have a sort of a placeholder unexpected failure in here. This allows us to use the node failure union as the return type. So let's put it inside either node failure, and let's also import node failure. So just like that, we now have the first watch all method. Let's duplicate it below, and we're just going to rename it to watch uncompleted. As you can see, it has the pretty much same definition except for the name. The difference will be only in the implementation of the method, which we are going to touch upon in the next parts. So next up, we have three CUD methods. So create, update, and delete. They will again have very similar definitions. They are all going to return a future, which will hold an either type, which can either have a node failure or unit. And why unit? Why not KTList node as in the methods above? Well, that's because create doesn't really have any return type. So whenever create is successful, we are going to just return unit, which basically means void, which in turn means nothing. However, it surely can have some sort of a failure occurring whenever we create a node. So that's why we use either node failure unit. And also we need to tell this method which kind of a node we want to create. This node will arrive from the node creation form from the UI. So we need to pass in the node. And now let's duplicate or triplicate it below. We're going to update the names to update and delete. And that's it. We now have the abstract interface inode repository fully done, and it's just waiting to be implemented in the next parts. And we have also created the node failure. So with this done, we now have the nodes domain layer all done, and we can now move over to the next layer, which is going to be the infrastructure layer. So currently we have only the infrastructure layer for the auth feature. So let's create another folder in there, and we're going to call it nodes. Just like with the auth feature, we are going to need to map between our validated value objects, which are present inside entities, because if you look at, for example, this node entity, there is just no way that we are going to be able to simply store a validated node body inside Firestore or inside any other database for that matter. So the same goes for list 3. We need to convert that to a regular list, which basically the JSON model of Firestore can understand. The same goes for node color. We cannot store a node color. We need to store the actual number for the color. And with IDs, the difference is completely striking. The ID is not actually going to be inside the document in Firestore. Instead, ID will only identify the document. So basically, it's going to be sort of separate from all of the other data which is present inside the node. We just have it inside the node entity for organizational purposes in our app. But as far as database is concerned, IDs are not really a part of the data. It just identifies the data itself. So with this kind of a lengthy description of why we need data transfer objects, let's begin creating them, right? We didn't create them for the auth feature. We just created a Firebase user mapper to domain. That's because the basically data transfer object for our authentication feature is already just the simple Firebase user, which comes from the Firebase auth package. So basically Firebase auth package already defined and implemented the data transfer object for us, so we didn't need to do it ourselves. However, we don't have any such benefits when it comes to our own nodes feature, so that's why we need to implement the data transfer objects ourselves. So let's right-click on the nodes folder in the infrastructure layer, and we are going to create a node DTOs file, node DTOs.dart. And this file will hold both the ToDoItem data transfer object and also the node data transfer objects. It will hold two of them basically. And let's start off with the simpler ToDoItem data transfer object. So let's first open up the entity to know what we actually want to store in there. So we want to have simple representations for ToDo name and done, and then also a simple representation for the ID. And then later on in the next parts, we are actually going to separate the ID from the actual data and just make it identify the documents in Firestore. So let's get to it. We are going to create a fData class, so freeze data class. Let's call it ToDoItem DTO. Some people prefer to do it like DTO, all in capital, but I just do DTO where TO is lowercase. You do you. Just please don't hate me for not following the conventions which maybe other people use. And we are going to import freezed. Also provide the PTF statement. And while we are at it, we also want to be able to convert these data transfer objects to and from JSON. So that's why we are also going to provide the regular PTS statement, which is the g.dart file for the JSON serializable package so that it can do its magic. Now, let's define the fields which are going to be present inside each and every DTO. So they are going to be required, all of them, and it's going to be string ID, then required string name, and lastly required bool done. So in other words, we have unwrapped the value objects into just their core things which they represent. Unique ID really represents only a string. The same goes for ToDoName. It really only represents a string, and all of the validation is just added on top of it. But remember that our inode repository accepts node entities, and the same goes for ToDoItems, which are nested inside the nodes. They are going to be ToDoItem entities, not data transfer objects. And it's going to be inside the repository implementation where we want to convert the entities which are validated into just simple data transfer objects. So we need to have a way to convert an entity into a DTO and vice versa. So the next thing we're going to provide in the ToDoItem DTO is going to be the conversion factories and methods. Because we want to keep our domain layer completely independent from outside influence, all of the mapping is going to happen here inside the DTO, and nothing will go into the entity. So here we want to define both the from domain factory. So let's do it right now. Factory, ToDoItem DTO, from domain. And just like it says in the name, we are going to use this factory to construct the data transfer object from an entity which is present inside the domain layer. So it will accept the ToDoItem entity, that is. Let's call it ToDoItem. And what do we want to do here? Well, we want to, of course, return a ToDoItem DTO and populate all of its fields using the passed in entity. Now, ID should be populated to ToDoItem.id, but the problem is that ID is of type unique ID, and we need it to be in the simple string format. So how can we do that? Well, we're going to say get or crash. And this is precisely what we should do, because at this point, when we get here to this from domain conversion method, that means that we have already passed the node form, the UI where the user inputs data for the new node the user wants to create. And it's the responsibility of that form, of that presentation layer, to stop the user from progressing to the next step, which is going to be to upload the node to Firestore or wherever else. In other words, if we get a crash from this line of code, that means we have made a mistake somewhere in the previous steps. That means that this crash is actually a good thing, because it's going to tell us in the Crashlytics or in another service which we use that we have made a serious mistake and we should fix it ASAP. This crash should actually never happen, and if we are good programmers, it's also never going to happen, because we are going to stop the user from progressing in the presentation layer, and it's not going to even get to the infrastructure layer at all. So the next thing is name, and the same goes for this too. So ToDoItem name get or crash. And lastly, done. This is just a simple Boolean, even inside the ToDoItem. So we're just going to say done, and that's it. So this is the from domain conversion. But whenever we receive a ToDoItem from Firestore or from some other source of data, we are going to receive it as simple data, as string, string and boolean, and then the other layers of our app are going to want to communicate in terms of ToDoItem entity, not ToDoItem DTO. And this conversion from DTO to domain entity is going to happen inside ToDomain method, which is going to return ToDoItem. This is the entity ToDomain. And now, because we are including a regular member function here, we need to change the definition of our freezed data class. So instead of with, we are going to say implements. And also we need to provide the default constructor. So ToDoItem DTO, it's going to be private. And now we can have a method right here. We are going to return a ToDoItem entity, which is going to hold ID, and we're going to populate it with unique ID. That, and here is the place where we are going to use the from unique string constructor to provide an already present ID, which we can guarantee that it's already unique because it's coming from Firestore after all, or from other sources of your data. And we want to pass in the ID present inside the data transfer object. Then the next field is name. We want to wrap it inside ToDoName. So name comes in there from the DTO. And lastly, done. So this is going to be only done because it's just a simple Boolean again. And lastly, we want to include the functionality to convert this data transfer object to and from JSON. And we are going to use the JSON serializable package for that. And because we are also using freezed data classes, the process of adding to and from JSON is a bit different than with usual classes. All we need to do is to provide the from JSON factory, and the generators of freezed and JSON serializable are going to do the rest of work on our behalf. And I actually have a code snippet from JSON. So let's provide the ToDoItem DTO name here, and the code will be generated successfully. So now we have still some sort of an error. That's kind of interesting that it wasn't generated. Why is that? Maybe we don't have the JSON serializable package yet, I guess. Yeah, we probably don't. That's kind of a bummer. So let's add it right now. But basically, you can get this code from the link in the video description if you don't have the snippets yet copied from some second part or whenever it was. Okay, so guessing that we do not have the JSON serializable package yet, let's go over to pubspec.yaml and try to find it, right? So we have darts. No, we really don't have it. So let's add it right now. And please use the same versions as I am using here, because I cannot guarantee that there are not gonna be any breaking changes in the future. So I'm going to use the pubspec assist to add or update dev dependency. We're going to search for JSON serializable. The current version, so it seems, is 3.3.0. Let's also add the latest version of JSON annotation as the regular dependency. JSON annotation. So we have just added JSON annotation and JSON serializable, which is the generator. And then while we are at it, let's also add the Firestore package, because currently we have only core and auth packages when it comes to Firestore. So let's add dependency cloud Firestore, Cloud Firestore, and let's move it to all of its friends from Firebase up here below auth. So now Cloud Firestore 0.13.6, JSON annotation 3.01, and JSON serializable 3.3.0. So make sure to use these versions, and you can also get them from the link in the video description where they are going to be available in the pubspec.yaml file. Now that we have all of this, the code generation was just stopped, so let's rerun it again. And this command is also available in the video description. And just like that, as you can see, now we have even the g.dart file generated, and it's all looking good. That is it for the ToDoItem DTO, but we also want to have the node DTO. So let's actually create it above the ToDoItem DTO. It's going to be again a freeze data class, so fData class. Let's call it node DTO. And this one is going to have all of the members of a node entity, but they are going to be stripped of their validated value objects. So the constructor will hold optional required parameters, which is going to make them named. They are going to be string body of the node, so add required string body, required int color, and lastly required list, which is going to hold ToDoItem DTO, which we have just created a while ago. So it's not list 3, just a regular list, and it's not even a KT list, just a regular, really mutable list, which comes with Dart to-dos. And actually, we are also going to have the string ID, but here it's actually not going to be required. Technically, we could have completely excluded the ID from the ToDoItem DTOs and also from the ToDoItem entity. The ID field could really not even be here because of the way that we are going to store to-dos in our database. They are just going to be an array of to-dos nested inside the node document. We're going to get to that later on. But because we are trying to make this app work for other types of databases too, we are storing an ID for the ToDoItem entity. Because if you were using something like Postgres, then you would have relationships between the ToDoItem and the node, and that would really require you to have an ID even for the ToDoItem. In our case, we do not need it. But because we want to populate this unique ID in the ToDoItem, just so that this code is valid for other approaches to to-dos as well, that's why we are going to store the ID of to-dos inside Firestore. However, in the case of nodes, we do not want to store the ID inside the database along with all of the other data like body, color, and to-dos. Instead, we want the ID to be only an identifier for the data collection. So when we do something like JSON, let's specify JSON somehow here with multi-line comments. So we're going to have a JSON holding the body, some string. Then we're going to have the color, some integer representing a color, something like this. And lastly, we are going to have a list of to-dos. This will be a list. Of course, the coloring jumps in, but that doesn't matter. So this will be a list holding some to-do items, all right? But nowhere in here are we going to store the node ID. Instead, the node ID will only be the identifier for this whole document held inside Firestore, okay? And because we do not want to store the ID along with all of the other fields, we are going to make it be ignored by the JSON conversion. So we are going to annotate this ID with a JSON key, and we are going to say that ignore is true. And now when we provide a from JSON factory, again, I'm going to use the snippet, and you can get this code from the link in the video description. Let's give it the name node to do, or node DTO, excuse me. And now we take a look at the generated file. We can see that the node DTO from JSON and to JSON has no ID present in the converted map fields. We just have body, color, to-dos, and the ID is nowhere to be found. That's because in the next part we are going to use the ID as the document identifier. But again, we include ID for demonstration purposes, I guess, inside the ToDoItem DTO, although, as I have said, this ID could be completely omitted from here and it would be also just fine. Before we go ahead and simply implement the from domain and to domain conversion factory and method, let's think about how we want to sort the to-dos. We probably want to sort the not to-dos, but DTOs, the nodes, by the time they were last updated. You know, the most recently updated or the most recently added node is going to be visible on the top of the list, and then the oldest node will be at the bottom of the list, as usual in these kinds of note-taking or to-do apps. So this means we need to hold the last time of update inside Firestore so that we can then order the data by this timestamp, right? So are we going to store in here something like at required datetime and time? Technically we could maybe convert this datetime to the milliseconds since epoch, but there is also a better way to store timestamps inside Firestore, specifically timestamps which deal with the last update of a document. We are going to store here, instead of a datetime, something called a field value, which is absolutely Firestore specific. It comes from Firestore, and we are going to call this server timestamp. If we take a look at this field value, it says Sentinel values that can be used when writing document fields with set or update. So Sentinel values means that they are not really going to be present or passed into this DTO from within our app. Instead, whenever this kind of a Sentinel, let's say placeholder, in other words value, arrives in Firestore, it's going to be converted from this placeholder value to a real value holding some actual data. In this case, we want it to be converted to the time on server when the node has been updated or written to. Now that we know this, we can go ahead and implement the conversion factories and methods. So first up, we're going to have factory, node DTO, from domain, and it's going to accept a node entity, node, and let's say return node DTO, and we're going to populate the ID with notes.id.get or crash. Of course, we first need to import notes, get or crash. We're doing this conversion even though the ID is actually ignored in the JSON output. You're going to see why in the next parts. We're basically going to use the node DTO to also populate the document ID in Firestore. Then body is going to be node body get or crash. The same goes for color, node color get or crash. And to-dos are going to be a little bit more interesting. That's because node to-dos is not just a regular list, it's a list of 3, which holds to-do items. So we have 2 jobs here. We need to convert both the list 3 and to-do item entity into their simple data representations. So the list needs to be, of course, gotten or crashed. And then we want to call map on the KT list. So map, let's import KT Dart. So package KT Dart /KT Dart. Dart, or maybe kt.dart. Yeah, now we're rolling. So let's import this thing here. Now we can call map, and now our job is to convert the to-do item entities, which are held inside this KT list, into just regular to-do item DTOs, which we have created down here. So we're going to say to-do item DTO dot from domain and pass in the to-do item. And then we do not want to store a KT list inside the to-dos field in the node DTO, but instead we again want to simplify it to be just a regular list with which the JSON serializable package can work. So we're going to say as list. And just like that, this code is now quite workable. And we can see that we have some sort of an error inside the color conversion. So, oh, I see. The issue here is that we want to represent color as only an integer inside Firestore. But this get or crash returns a color object. So we need to extract the integer from this color object, and we can do that by calling value, which gives us a 32-bit integer, which is just a regular integer representing a color. Lastly, we need to populate the server timestamp field, or yeah, server timestamp, and we're going to populate it with field value and select the server timestamp from here. So now, once this data arrives inside Firestore, all of the regular data will be written immediately, but then Firestore is going to notice that this Sentinel server timestamp value has been passed in, and it's going to convert this Sentinel value to the actual time which is currently present on the server. Now let's go and implement ToDomain. Again, we need to change the definition to implements and also provide the default constructor, which is going to be just private. So let's say const node DTO underscore parentheses like this. We again have some issues with node DTOs.g.dart. I'm not sure why that is. We shall see what's going to happen next. I'm not sure why we have issues, but anyway, we're going to now create the node returning function ToDomain, which is going to return note. And we're going to populate ID, unique ID from unique string, passing the ID from the data transfer object. Next up, we have the body field, so note body this time, pass in the body from the data transfer object. This is basically like calling this .body, but since this prefix would be redundant, we can remove it and just say body instead. Then color is going to be a note color, which will be gotten from a color held inside our integer called color. And let's import color from Dart UI package. And lastly, we have to-dos, which are going to be a list3 to-dos .map, and we want to map our ToDoItem data transfer objects into entities. So this DTO is of type ToDoItem DTO, and we want to call ToDomain on that, which is the function we have implemented a while ago in this part. So now that we have entity representations of our ToDoItem DTOs, now we want to convert this simple list, or this simple iterable rather, into a KT list, which our list3 value object expects. So we're going to say something like toImmutableList, which is an extension provided by the KT Dart package. And now we have even the ToDomain method sorted. So we have from domain to domain, from JSON, but in addition to from JSON, this note DTO, which is going to be stored inside Firestore, will also greatly benefit from having a from Firestore method. It will be very similar to from JSON. It's actually going to use from JSON, but it will know about one more thing, about the ID of the Firestore document. And again, ID of a Firestore document is not something we are going to have inside this map string dynamic JSON coming from Firestore. That's because ID is not a part of the document itself. It's just a separate identifier. It's not a part of the data. So we need to create a factory on node DTO, let's call it from Firestore, which instead of accepting map string dynamic, it's going to accept something very Firestore specific again, which is going to be a document snapshot, which just represents a document at a certain point of time in Firestore. We're going to receive this inside our repository implementation. And let's call this doc for document. And inside here, we want to return note DTO and use our from JSON, which is generated for us by the JSON serializable package. And the JSON, we want to come from the document data. We can obtain the document data by calling doc.data, which, as you can see, is a map of string dynamic, and it contains all the data of this snapshot, and this is precisely what we want. But then we also want to populate the ID of our node DTO. So we are going to say copy with ID, and it's going to be gotten from doc.documentID. So now, even though the document ID is not a part of the data, we now can use this ID throughout our app because we have gotten it from the document snapshot. And now we just need to solve the issue of why we have an error saying that the regular g.dart file, which should hold the JSON serializable conversion methods does not want to be generated? Well, the issue stems from this server timestamp field. That's because JSON serializable can convert by default only fields which are valid in regular JSON. So those are strings, integers, booleans, doubles, and so on, and lists, of course, and also other maps. But a field value is not really a regular JSON field. It cannot be held inside a regular JSON. Field value is only available inside a sort of a superset of JSON which Firestore operates with. But JSON serializable does not have any clue about Firestore. It just operates by the regular JSON standards. So that's why we need to provide a little bit of a nudge to the JSON serializable package to tell it that, hey, we actually do want to use this field value inside our converted JSON. We can accomplish this by creating a custom converter, which we are then going to use. So let's do that right now. Let's scroll down, and right above the ToDoItem DTO, we're going to create a very simple class, server timestamp converter. It's going to implement JSON converter, which comes from JSON serializable, implements, and we need to provide generic types. The first type is the from JSON conversion result. It's going to be field value. And the output of the to JSON conversion should be just a plain base object, which is the base class of all the classes in Dart. And here we want to implement first the from JSON method. So whenever data arrives from Firestore, we're going to receive a JSON object representing the particular field which we are converting. And we actually don't care about the value of the field which we are converting from JSON. We are just simply always going to return field value dot server timestamp. This is all that our field is going to ever hold. It just holds the server timestamp, which is some sort of a static method which returns a field value instance. So this is when we are converting data from JSON to our DTO. But when we are converting from our DTO to JSON, this is the most important part of this converter, by the way. So to JSON, it's going to be just an expression bodied method. So arrow here, and here we can do the unspeakable thing of including an object inside JSON, which is by default not supported by the JSON standard. So again, we can input here the field value. Let's just rename the object to field value to make it more apparent. And just by doing this, we've done something unspeakable, that we have basically broken the standard JSON format, which of course cannot hold a field value object, but now we can store it as an object inside our JSON output. Now, in order to use this converter, we need to be able to use it as an annotation. And you may know that annotations in Dart, they have to be constant. So that's why we are going to create a constant constructor for this class. So const server timestamp converter. This is just something you have to do if you want to use a class as an annotation. And by the way, if you want to learn more about constants in depth, you can check out the tutorial from the card in the corner. Now, all that's left to do is to scroll up, and where we have the field value field, we want to annotate it with server timestamp converter and instantiate it. And here we go. Now, once we save this file, you can see that the red squiggly line has disappeared from below the nodes.dtos.g.dart file, and it's using the server timestamp converter just fine. If you want to get all of this quite lengthy code from this part of the DDD tutorial series, be sure to check out the link from the video description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education. Link is also in the video description, by the way, to get the top curated Flutter news and resources aimed at improving your app development career. Over there, you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you don't want to miss more tutorials like this, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. In the next part, we are going to move further into the infrastructure layer, so you have surely something to look forward to. And if this video helped you with implementing data transfer objects along with this conversion and using the server timestamps on Firestore, give this video a like and also share it with other developers who are surely going to find it beneficial too. Leave a comment if you have anything to say, and see you in the next video.